Chapter 3 Review. So question 2a asks you to copy and complete the table of values to find the rate of change. So this is the table that you have in your book. And to find the rate of change, it's the difference between the y values. So you go from here. So you're going to get a difference of 3, because 1 minus -2 equals 3. So next you go to the next set, and you have 4 minus 1, which is 3. And you continue like this the whole way down, finding the difference between each y value. So you'll find that the whole way will always be 3. Question B asks what is the relationship between the rate of change and the slope, and they are the same. When you have your graph, and you have your linear line, between each point, the slope is the same. It remains constant the whole way along the line. Similarly, the rate of change is the same the whole way along the line. We can prove this by finding out what the slope is. So, slope is rise over run. So you'd have rise over the run between any points. So, I'm going to pick this one and this one. So your rise is the y value. So you find the difference between your y values and your x values. Y being your rise and x being your run. So 1 minus -2 divided by 1 minus 0. It's important that the points line up. So if you look at this one first, you'll notice that I used them first. And then this other one came second. So then we have 1 minus -2 is the same as 1 plus 2. So we have 3 over 1, so the slope is 3. And it matches. For the y-intercept is when x is 0. So it's when it's crossing the y-axis. So your y-intercept here would be -2, which is found by looking at your table of values, and it's the first yellow circle there. And then finally you are asked to find the equation. So you know that y equals mx plus b, where b is your your y-intercept and m is your slope. So you just have to sub in to end up with y equals, and you have a slope of 3, x minus 2. It's important to notice that there's a minus here, not a plus, because it's -2. Question 3. A downtown parking meter allows 15 minutes of parking for 25 cents. So 15 minutes for 25 cents. Okay, so question A asks you to create a table of values in increments of 15 minutes for the cost of parking up to 2 hours. So, x is time. So we're starting at 0, then 15, 30, 45, 60, 75, 90, 105, and 120. So here's your 1 hour mark, and here's your 2 hour mark. So with every 15 minutes being 25 cents, when you haven't parked there, it's going to be 0. After 15 minutes, it's 25 cents. And we'll go up to 15 or 50, 75, $1, 125, 150, $1.75, and $2. And you'll notice that it's going up by 25 cents each time. So for every 15 minutes, you're adding an additional 25 cents. So that's A. And then question B is asking you to graph it on the graphing calculator. So I'll just sketch it for you. So it would look something. So knowing it starts at the origin, it would go up linearly. And it's asking for a scatter plot, so you don't have to connect them. But it would look something like this. And then C says explain why this relationship can be modeled with a linear equation. So it's a linear equation because it's increasing the same amount between each point. So although my graph isn't particularly accurate, given that it was just freehand and done without graph paper, it would be a completely straight line. The slope is the same anywhere along this line. So if you were to choose this point and this point, the slope between the two would be the same as between this point and another point. For question 4a, you have a graph that looks similar to this, and you're asked to find the slope using rise over run. So I'm going to use the 2 points that they've given us, which is 4, 7, and this one is 2, 3. So we're using m equals rise over run. So our rise is the y-axis, and the run is the x-axis. So I'm going to take my first point, and we've gone from, so for the rise, we've gone from 3 up to 7. So you're going to subtract them. 7 minus 3. And then for the run, we've gone from 2 over to 4, so 4 minus 2. And similarly to the other question, you're going to notice that the points will again line up. You have 4 and 7 in the same column, and you have 3 and 2 by each other as well. So then you get 7 minus 3 is 4, 4 minus 2 is 2, so our slope is 2. For 4b, you have a graph that looks like this one, and again, I'm going to use the points that were marked. So we have -1 and 8, and we have 1 and 2. So for the rise, we're going to go from 2 up to 8. And then for the run, we're going from -1 over to 1. So 8 minus 2 is 6, -1 minus 1 is -2, so you end up with -3 as your slope. So for question 4c, again you're given a graph that looks like this one with 2 points on it. This one is -4 and 1, and this one is 5 and 4. So rise is going to be from 1 up to 4. So 4 minus 1. And then our run is going from -4 all the way over to +5. -4. So 4 minus 1 is 3. 5 minus -4 is 9. 3 divided by 9 is 1/3. Number 5 is asking you to use a graphing calculator to graph the 4 graphs. I'm going to skip that one just because I don't have a graphing calculator. And I'm going to move on to number 6, which even though you're using the graphs from part 5, you can still do it without that. So for 6a, it wants to know which lines have a positive slope. So knowing the equation y equals mx plus b, so they're asking for a positive slope. So they're looking for the m value to be positive. So you can see a positive m value in graphs A and D, because in A you have a positive 3, and in D you have a positive 3/4, whereas the other two are both negative. You have -1 and -1/4. So that's A. For B, it's looking for which ones have a negative slope. So if they don't have a positive slope, they're going to be negative. So B and C are both negative. You have -1 and -0.25. For C, they want to know what the y-intercept is. So the y-intercept, again, going back to the y equals mx plus b, it's the b value. So for graph A, the y-intercept is -5. For graph B, the y-intercept is +2. For C, it's +7. And for D, it's -3/2. For part D, so they want an equation of a line that is parallel to each of these lines. So in order for something to be parallel, you're going to want it to look, so you want a line like this one and this one. So when you're looking at what's different, you'll notice that the slopes are the same because they're increasing or decreasing at the same rate. However, their y-intercepts are different. So you can just take the equations from question 5 and change the y-intercept. So change the b value, and you'll come up with lines that are parallel. There are many different ways to do this, so I will just leave it at that and trust that you can change a value. For part E, we're now looking to create lines that are going to be perpendicular. So we're going to, here I'll sketch off to the side again. So you have your axes. So say this is your graph. You want one that's going to be perpendicular. So you want it to go something like this, where it's forming a 90-degree angle with your line. So in order to do this, again, the slope is going to be the same, except for it's going to be the opposite. So whereas the first line that I drew, this one here, has a positive slope, this one's going to have to be negative. Also, you'll notice that the y-intercept can be anything, because you can have the line that I just drew, or we could have, this one's also perpendicular, or this one, or this one. So all of those could be options, and they all have different y-intercepts. So we will just leave those written as B for now. So for A, or graph A, where you have y equals 3x minus 5, a graph that would be perpendicular, so you're going to take the slope, you have to invert it. So when you have 3 as a slope, that's the same as saying 3/1. So we want to invert it and make it negative. So the perpendicular line would be y equals -1/3 x, and then any b value. So that, like I said before, can be anything. So then for graph B, to find a perpendicular line, you have y equals -x plus 2. So your perpendicular line would be, so when you have a negative there, that's the same as saying that there's a -1. So negative 1x is essentially what's there, which is the same as saying 1 over 1. So rewriting that isn't necessary. So you just have to flip the sign. So it was negative, so now it's going to be positive, and then the b value can be anything, positive or negative, depending on where it's going to be crossing. For graph C, you have negative 0.25 is the same as a quarter, x plus 7. So change the sign and flip it. So you're going to have y equals 4 over 1, if you'd like, x, and then any b value. And finally, D, you have y equals 3/4 x minus 3 over 2. So again, you're going to flip it and change the sign. So you end up with y equals 4 over 3, it's negative x, and then any b value. Question 7a. So you're given two tables of values and you're asked to state whether the lines in each pair are parallel. So you're going to want to find the slope and the y-intercept for each table. So for the first one, I'm going to take table of values. I'm just going to use the first 2 points to do rise over run. You have your x and your y. So for your rise, which is in terms of y, these guys, we've gone from 0 all the way up to 3. And for the run, which is the x values, we've gone from 0 to 1. So that's the same as 3 over 1, so your slope is 3. Your y value is when the x value is 0, so you're going to have that as being 0, which I just pulled straight from the table. For the other table, again, table of values with the first 2. So you have 0, which is negative 12, and 1, which is 9. So you've gone from negative 12 to negative 9. And you've gone from 0 to 1. So this is going to be 3. So it's the same as having a slope of 3. And your y-intercept, again, when x is 0, is negative 12. So if I were to graph this, you'll see that they're parallel. So we'll have a line coming through, something like this, where this is negative 12. And your slope is 3. And then you have a line with the same slope coming up like this through the origin. M is 3. So yes, they are parallel. For 7b, again, you're asked the same question. You're going to want to find your slopes and your y-intercepts. And you're going to have your table of values, your x and your y. So I'm going to use the first 2 again. So you have 0 and 10, 1 and 7. So you've gone from 10 to 7. So it's decreasing. So you're going to have 7 minus 10 divided by 1 divided by, or minus 0. So you're going to have negative 3 divided by 1, so your slope is negative 3. Which makes sense, because if you look at the rest of the values, you'll notice that the y values go down as the x values go up. So it would look something like this. And then for the second table, it would be x and y, so you have negative 1, negative 10, and then I'm going to choose 0 and negative 7 just so that I can stick with whole numbers. So you'll notice that you've gone from negative 10 to negative 7. So negative 7 minus negative 10 divided by, you've gone from negative 1 to 0. So this is the same as 0 minus negative 1. It's the same as being 1. And then negative 7 minus negative 7 minus negative 10 is the same as negative 7 plus 10. That gives you a positive 3. And then your y-intercepts are when x is 0. So up here we have a 10, and here we have negative 7. So you'll notice that these two are not going to be parallel. We will have a y-intercept of negative 7 and being positive 3. So this is the second table because it's positive. This is negative 7. Whereas the other one has a y-intercept of positive 10 and is a slope of negative 3. So it would look something like this, with m being negative 3. Something that is worth noting is that this will not form a right angle as it is not parallel. Even though it switched signs, it did not invert the slope. For it to be parallel, if we were going to be parallel to this one would have to be negative a third, or sorry, not parallel, perpendicular. If we were going to be perpendicular to this one, this would have to be positive a third. So this isn't parallel and it's not perpendicular. It's just two graphs that are intersecting. Question 8. So here we are asked to find the equations of the line in question 7. So you had already found the slopes. So for 7a, we found slope to be 3 and the y-intercept to be 0, and then the other one was slope of 3, y-intercept of negative 12. So these two equations, so remembering the y equals mx plus b, we would have y equals 3x plus 0, which is the same as being y equals 3x. And over here we would have y equals 3x minus 12. For part B, we had m positive, or negative 3 was the first one, and the second one was positive 3, and y was 10, and here negative 7. So for the equation, you get y equals negative 3x plus 10, and y equals 3x minus 7. Question 9. So here you're given different information for different equations and asked to find the equation of each line. So for number A, first it's important to remember y equals mx plus b, with this being the y-intercept and m being the slope. So then that makes these really easy, you just plug them in. So A, you have y equals, and they tell you the slope is 4x, and the y-intercept is negative 3. B, you have y equals, slope is negative 2.7, and the y-intercept is positive 6.3. C, it's going to be y equals the slope, which is 0x, and the y-intercept is positive 2.5. So this one's important. You'll notice that it simplifies to y equals 2.5. If you were to graph this, it would be a graph that has no slope and crosses y at 2.5. So it goes like this. It doesn't increase, doesn't decrease, it just stays horizontal and would cross at 2.5. D. So you have a slope y equals the slope, which is 2.5 x plus the y-intercept, which is 0, so this is the same as 2.5x.
Question 10. So for this question, you're asked to determine the equation of each line. So we're going to be using y equals mx plus b. So you know that m is your slope and b is your y-intercept. So as a quick reminder, your y-intercept, so if you had your graph, is when whatever line, the y-intercept is when it crosses the y-axis. So it's when x equals 0. That is important to remember. So going back. Okay, so for A, you know that your slope is 2, so m is going to be 2. And then you're given a point that it goes through, so it's going to go through 3, 8. So again, quick reminder, 3 is your x value, and 8 is your y value, so you can plug them in. So when you plug them into your equation, first your equation, you have y is equal to your slope times x plus b. So you still don't know what b is, but you have been given values for x and y, so you're going to plug those in. So y is 8, so you have 8 equals 2 times 3 plus b. So if you solve this one, so you get 8 is equal to 6 plus b, so you're going to have to subtract 6 from both sides. 8 minus 6 is 2, this is 0 plus b, so 2 is equal to b. And if you want to check your work there, so I'll do the check in blue. So if that's your y-intercept, then when x is 0, then y is equal to 2, which we know will work because when you multiply 2 by 0, you get 0, so y is equal to b, which is 2, so it works. So your final equation then, you just plug your b value and your m value in. So your final equation would be y is equal to 2x plus 2. Moving on to b. So here you have a slope of -3. Oops. M is -3. And then again, you're given a point, 2, 5. So again, you start your equation, so you know y is equal to -3 because that's your slope, x plus b because you haven't been given your y-intercept. So the only thing we can do at this point is plug in the values that you've been given. So 5 is equal to -3 times 2 plus b. 5 is equal to -6 plus b. So we're going to add 6 on both sides. 11 is equal to b. Plug it into your equation. You get y is equal to -3x plus 11. Part C. So you have a slope of negative 2.5. So m is negative 2.5. And then it passes through the origin. So when you have your graph, the origin is this point. So it's when x is equal to 0, y is equal to 0, so it's at 0, 0. So your point that they've given you without actually saying it is 0, 0. So we're going to do the same thing as before. So your equation is y is equal to negative 2.5x, because that's your slope, plus b. So we're going to plug values in. 0 is going to be equal to negative 2.5 times 0 plus b. So negative 2.5 times 0 is 0. So you have b is going to be 0. So your final equation would be y is equal to negative 2.5x. Again, so question D, you're given a slope of 3/4, and it's going to be passing through 2, 2. So again, start your equation. So you know your slope is 3/4, x plus b, so you're going to plug them in. So 2 is equal to 3/4 times 2 plus b. So you end up with 2 is equal to 1.5, or 1.5, plus b. So we have to subtract 1.5 from both sides, leaving a half is equal to 0 plus b, so the half is b. And then you put it into your equation. Y is equal to 3/4 x plus a half. Part E, similarly to all the other ones, your slope is going to be negative 1.4, and it's going to pass through negative 7, 7.5. So we're going to start our equation. So you know what your slope is, so you're going to plug it in. And now we're going to sub in the points that we've been given. There we go. And we solve the first part. So negative 1.4 times negative 7 is 9.8 plus b. So we have to subtract 9.8 from both sides, which will leave us with negative 2.3. It's going to be b, giving us y is equal to negative 1.4x minus 2.3. It's important to remember that whatever sign is here goes here. For question 11, you're asked to determine the equation of each line, and for each one you've been given 2 points. So, question 11a. So the 2 points you've been given are negative 3, 6, and 9, 0. So for this one, I'll actually start by sketching it quickly. Whoops, if I can draw a straight line. Off to the side, it's relatively straight. So we're going from negative 3, 6, to 9, and 0. So it would look something like that, but if you were asked to draw it, you would draw it nice and straight with a ruler and not have it all wavy. So because it's going down off to the right, you know that your slope is going to be negative. So that's a good thing to notice. Okay, so we have slope we know is rise over run. So your rise is how far up and down it goes. So it's the change in the y value. So we're going to be going from I'm going to go from 6, because that's where we are up here, down to, so we're going from 6 down to 0. And then we're going for the run, it's the change in the x value. So we're going from -3 to 9. So this is equal to 6 divided by -12, which is equal to -1/2. So that's going to be your slope, which we've been writing in red, so I'll keep it with that. So now, similar to what you did in question 10, you have a slope value, and you have an option of 2 points. So you can plug it in using either point. So you have the start of your equation, which is y is equal to your slope, -1/2 x plus b. So I'm going to plug it in using the second point given, just because there's a 0, which generally makes things a little bit simpler. So 0 is equal to -1/2 times 9 plus b. So you end up with 0 is equal to -4.5 plus b. So we're going to add 4.5 to both sides. So you end up with 4.5 equal to 0 plus b. So 4.5 is equal to b. I think I've been using blue for that one. So now you can take these two values that you have and write your final equation. So you'd end up with y is equal to -1/2 x plus 4.5. Okay, moving on to b. So here your 2 points are 1 and -1, and 5 and 5. So again, I'm going to do a poorly drawn sketch. So we have 1, -1, we have 5, 5. So it'll be something along the lines of that, except for your points would be on the line and everything would be straight. So from this, you're going to know that your slope is positive. It's always nice to draw a sketch, even when it doesn't ask you to. However, if you're confident that you don't need to, then go for it. I recommend drawing. I also like drawing. So, again, you're going to find your slope. So it's rise over run. So rise is going to be a change in your y values. So we have, you're going from -1 all the way up to 5. And then for your run, you're going from 1 all the way over to 5. So this is the same as -6 divided by -4, which is the same as +3/2. So there's your slope. And now we're going to do what we did back in question 10. I'm going to choose, again, the second point because I don't like working with negatives when I have the option not to. So you're going to have the start of your equation, y is equal to 3/2x plus b. Now we're going to sub in 5 is equal to 3/2 times 5 plus b. So 5 is going to be equal to 7.5 plus b. Subtract 7.5 from either side, leaving us with negative 2.5 is equal to b, but is equal to, those go to 0, plus b, so negative 2.5 is equal to b. So there's your b value, and your final equation, all right, up here in green, is y is equal to 3 over 2x minus 2.5. Again, it's very important to remember to carry the sign that is in front of the b all the way up to your equation. Okay, question C. Your 2 points are 2 and 500 and 10 and 500. So, again, poorly done little sketch over here. So we're going from 2 500 to 10 500. So you'll notice that this is one of those special ones that often is talked about that is horizontal. So when you have a line that is horizontal, m is 0. There's no slope. It is not going up. It's not going down. So I can prove that by, so you end up with, so you're going from, so you have your rise, oh, here. Writing it out properly, we have slope is rise over run. So your rise, you've gone from 500 to 500. So that's this, or the lack thereof. And then your run is going this way. So you've gone from 2 to 10. So 0 divided by 8 is not possible. So there's no slope. So I'm going to choose the first one to plug it into, on the grounds that I've been choosing the second one a lot, but you could choose the second one, it doesn't make any difference. So y is equal to 0 slope plus b. So plugging in, we end up with 500 is equal to 0 times 2 plus b. So 500 is equal to 0 plus b. 500 is equal to b. Which makes sense, as we can see back in my silly sketch over here, that it crosses at 500 because it stays at the same value the whole way across. So your final equation would just be y is equal to 0x plus 500, which is the same thing as y is equal to 500. Okay, 11D. So we're passing through negative 4.5, 8, and 2.5. Oops. Write that a little neater. 2.5, negative 6. So, again, poorly done sketch. We have negative 4 and 8. We'll go here. And then we have 2.5 and negative 6, which would be way down there. So you have your line. Notice that, again, your slope is going down towards the right-hand corner, giving you a negative slope. Those are always useful to recognize because it helps you check your math when you're actually doing it. So we have m is equal to rise over run. So our rise, we've gone from 8 down to negative 6. And then for the run, it's going this way. We've gone from negative 4.5 to to positive 2.5. There we go. Okay, so this is equal to, so 8 minus negative 6 is the same as 8 plus 6, which is 14, divided by negative 4 minus negative 2, which is negative 7, which is equal to negative 2. For your slope, negative 2. And back to like we did in question 10, you have your equation of y is equal to negative 2x plus b. You could pick either point. They're both pretty close to the same. They both have a negative and a decimal, so I'm just going to choose this second one for no reason at all, just because I feel like it. So, plugging it in, we have y is negative 6 is equal to negative 2 times 2.5 plus b. So negative 6 is equal to minus 5 plus b. So we're going to add 5 to both sides. So we're going to have negative 1 is equal to 0 plus b. So negative 1 is equal to b, which is that one. So then you write out your equation, which is y is equal to negative 2x minus 1. Again, remembering your signs, that one came from there, and this one came from down over here. Don't forget your signs. It's important. Okay, question 12. So a $200 bond earns simple interest at a rate of 3% per year for 5 years. So I'm going to write down the information first so that I have it. So we have a $200 bond. So we'll call that a bond. And 3% is the rate. And then it's for 5 years. So right off the bat, before going any further, I see that there's a percentage here. Very rarely do we ever work with percentages, and we definitely don't in this case. So I'm going to switch it to a decimal, so that's the same as 0.03. So question A. Question A. So how much interest does the bond earn each year? And they have a hint that interest per year is the same or is equal to the amount invested multiplied by the interest rate expressed as a decimal. So the interest per year is what we're looking for. So I'm going to call that I. And they've said it's equal to the amount invested, which is our $200, times the rate as a decimal, which we already found. So you can plug it into your calculator or do it in your head, and you'll get $6, and then they told you that's per year. Question B. Create a table of values for the value of the bond at the end of each of the 5 years. So, we're going to need a table. That's not straight. There we go. So we're going to start at 0, 1, 2, 3, 4, and 5. Okay, so at 0 years, so you've just put your money in, you're going to be at $200. So if we're making $600 a year interest, so after 1 year, we've increased it by $6. After 2 years, so we're going to add another $6. And again, all the way down. Perfect. So you'll notice that we've increased by $6 each year. We know to do this because our interest rate is an additional $6 every year. So, question C. graph the data from the table in part B. So this is one of those times where I have graph paper. Okay, so this is part C, and you've been asked to graph it. So at 0 years, you were sitting at 206. Your graph would have a better scale. Actually, here, I might be able to fix that. Let's try this. So if we get rid of the values that were already there, so we'll go, okay, for your graph, you'd be expected to have a better scale than this. I don't have much room, so I'm going to just adjust so that you can see what it would look like. So at 0 years, you're at 206. At 1 year, you're at 200. At 1 year, you're at 206. At 2 years, you're at 212. At 3 years, you're at 218. At 4 years, you're at 224. And at 5 years, you're at 230. So you have your line where you're increasing $6 every year. And you'll notice that it's linear. So for part D, we'll go back to here. So they want you to write the equation that models the value of the bond. So your equation. So you have y is equal to, your slope is going to be, you're going an additional $6 for every 1 year, right? So you're going to have your slope as being your rise of $6 over your run of 1 year. So your slope is equal to 6. So 6x plus b. So you could either pick a point from your table and do it like we did back in question 10, or you know what b is because b is the y-intercept, and you know that you're going to be crossing the y-intercept at 200 because that was your initial value when x was 0, so when you had gone 0 years. So your b value would be 200. So you end up with y is equal 6x plus 200. Question 13 asks you to go back to question 7a and graph the lines. I'm going to assume that everybody can graph at this point. If not, you can follow the directions of the various graphs that I've drawn throughout this. And what you should find is that, for question 13, your lines, so 7a, they should be parallel. Something vaguely like this. So, parallel with your proper values, and you're set.